Ready? So to finish up lesson 14, today we'll do the part about the rectangular and polar coordinates. So I want to do some review of things that we did last year, vocabulary, formulas. Remember, when we are talking about vectors, we use I hat and j hat, and each of those is a unit vector, which means it is 1 unit long. So I hat is the vector that goes straight to the right and is 1 unit long. So when we have 3 I hat, that means 3 times this vector, so 3 times as long in that direction. When we have minus I hat, it flips and it means we go 1 to the left. J hat is then 1 unit long going straight up. So minus j hat is 1 unit long going straight down. We then use that to talk about rectangular coordinates as one of the ways that we describe a vector. And for what I have here with the blue one, we went 6 to the right, and then we went 6 straight up. So with rectangular coordinates, we learned last year we could describe that as 6 I hat plus 6 j hat. For the red one, let's imagine that it really does end exactly on that lattice point, so that we are going 3 to the left and then 4 up. That one would have been minus 3 I hat plus 4 j hat. The minus saying that we went to the left instead of to the right to start that one. So far, so good. Rectangular means you are going across and then you're going up and down. So you're drawing 2 sides of a rectangle to get there. That's why it's called rectangular coordinates. When we talk about polar coordinates, we are talking about the origin as a pole, and we're going to spin around it. So we want to talk about what is the angle for how far we spin, and then how long is the vector. So somewhere on here, if I get down far enough, polar coordinates, we are going to have something that looks like r at theta to describe that. So the blue one up there, for example, would be very, very easy to describe. We have a right triangle, 2 sides are 6, so it's an isosceles right triangle. So how big is this angle? 45 degrees. And since it's a special right triangle, 1, 1, root 2, 6, 6, 6 root 2 would be how long the hypotenuse is, so that's how long the vector is. So the blue one in polar coordinates would be 6 root 2 at 45 degrees. We could have some that go into the second quadrant, or even the third. I might have had 5 at 200 degrees, which would mean from the origin, I rotate around in the counterclockwise direction, go to 180 degrees, go 20 past that, so that that's my total of 200 degrees. And I end up in the third quadrant with that one. Both of those I did with positive angles. We learned last year we can talk about rotating in the counterclockwise direction, which gives us a positive angle. But we also said we could start at the x-axis and go in the clockwise direction and have a negative angle. So I could have 3 at negative 45 degrees, which means I go this way to 45 degrees and have a vector that's 3 units long. Negative on the angle just says which direction we go. So let's start to review how we go back and forth between the 2 types of coordinates. So here is a vector. I purposely have drawn this one so that it does not end at a lattice point, so we can't just look at it and count boxes. Wherever it ends up, If we were wanting to do it in rectangular coordinates, that would mean we know how far we go left or right, and we know how far we go up and down. So if we start off and we know what those two numbers are, we know I hat and j hat, and we want to get how long it is, we want r, and we want to know what the angle rho is. So if we know those two numbers, how do we find the hypotenuse? Pythagorean theorem. So if we want to get r for that, we would say that r squared is I hat squared plus j hat squared. So r is the square root of I hat squared plus j hat squared. If we want to get the angle inside the triangle that we use, right triangle trigon, for these problems, if I and j are numbers that I know, what trig ratio am I going to use to get my angle? Tangent, because it's opposite and adjacent. So I can say that the tangent of rho is j hat over I hat. So rho will be the inverse tangent of j hat over I hat. Now, we are always going to draw the right triangles and use right triangle trig. So we're always going to get to a triangle where we have lengths of sides. Even if we are in one of the other quadrants where I hat and j hat are negative, our triangle is going to have positive sides. So technically, we will be doing the absolute value of j hat and I hat. We'll drop the positive and negative signs to figure out the angle inside of the triangle. And then we'll use geometry to figure out other things to fill in. Let's talk about what would happen if we were trying to go the other way. Let's suppose that we know the polar form, so we know r and we know the angle. And now we want to figure out what I hat and j hat are. So now these are our numbers. If I want I hat, it is adjacent opposite hypotenuse. So if I know the hypotenuse and I want the adjacent, which trig ratio? Cosine. So I can say that the cosine of rho is adjacent I hat over hypotenuse r, which means I hat is r cosine rho. I can do the same thing with j hat, that the sine of rho is j hat over r, so j hat becomes r sine of rho. And those are our formulas that we're going to use, so let's get those in our formula list on the next slide. That's where they come from, that's why they work. So if we are switching from rectangular to polar, so both of these mean we know the rectangular. That means we know I hat and j hat. If we want to get how long the vector is, it is the square root of I hat squared plus j hat squared. If we want to get the angle that's inside the triangle, rho is always going to be our angle that is between 0 and 90 degrees. To do that, and I'll change this absolute value instead of parentheses, inverse tan of j hat over I hat. We're just going to take the positive components, take the inverse tan. That will tell us the angle inside our triangle for doing right triangle trig. When we are finished, to figure out the real angle, so to find the actual angle theta, we will think about which quadrant we really need to be in. Will the real angle really be between 0 and 90, between 90 and 180, between 180 and 270, between 270 and 360? And we'll talk on the next slide about the geometry of how we figure that out. If we are going the other way, we have our formulas. If we know the polar and we are trying to get the rectangular, So if we know the polar, that means we know R and we know our reference angle. Then to get I hat, we will take R cosine rho, and to get J hat, we'll take R sine rho. That will give us two positive numbers, and then we will think about which quadrant to decide if those should be positive or negative. I will require sketches on all of these problems. I require that you show your work. What is it you are actually typing into your calculator? That must be written down. The Inspires have the capability to deal with some negative angles and angles that aren't between 0 and 90, but for this course you are required to do it the right triangle trig way. You may not put in other angles, and we're not going to deal with that. We're going to figure out the positives and negatives and actual values the way I've just described and the way I'll show you in the examples. The reason for that is that's what will help you be more successful next year and the year after in our pre-calculus and calculus classes. So as soon as it looks like we have that written down, we'll start talking about what I mean about thinking about the quadrants for figuring out what your angles really need to be. On this part, I strongly recommend that you do not make any attempt to memorize what I am about to show you here. Think about the geometry. I'm going to write it down for you, but think about the geometry when you're actually doing it. You don't need to clutter your brains with remembering this. So if we are going from polar to rectangular, so we know our theta, whether it's less than 90 or it's in any of the quadrants, we know what that angle is. And we need to figure out how big our reference triangle is, so what is that angle between 0 and 90 that we're going to use in our triangle. If we're in the first quadrant, no problem. If theta takes us here and we draw our triangle, theta and rho are going to be the same thing. Gets more interesting as we talk about other quadrants. If theta says we're really out here somewhere, so we know polar, so we know that. But we need to come up with the rho so that we can figure out I hat and j hat. Always draw the right triangle going to the x-axis. We need this angle right here. So if it's 180 from the positive x-axis to the negative x-axis, if this much of it is theta, rho is the piece that's left if we take 180 minus theta. If we go to the third and the fourth quadrants, if theta takes us here and we draw our triangle like this, that means we need just this piece right here. So we take all of this theta, we take away the 180 that's up above it, and we're left with that. So that's why we have theta minus 180. Finally, if theta takes us someplace in the fourth quadrant, so that is theta, but we draw our right triangle to the x-axis. The angle between the vector and the x-axis is this, so that's going to be 360 minus the rho, minus the theta will leave us the rho. So, everybody okay with what that's talking about? And does what I said make sense to you? I recommend just think about the geometry on each problem, since I require the sketch anyway to figure it out. If we want to go the other way, so this time we know what I hat and j hat are, so we draw a triangle. We take our inverse tangent, so we know what the angle is inside of the triangle. And now we're trying to find what to really write when we're writing the final answer in polar form. If we're in the first quadrant, that's easy. If we know that we took our I hat and our j hat, and we ended up in the second quadrant, so here was our rho, we know for polar, we really need this theta from the positive x-axis to our vector, so we need to take 180 minus the rho that we figured out. If I hat and j hat put us down in the third quadrant somewhere. So then we figured out this row. Before we write it in the final polar form, we need to take 180 plus that row to get the actual angle we're talking about for polar coordinates. And finally, if we ended up in the fourth quadrant, so I hat, j hat took us into the fourth quadrant. So here is the angle we find with right triangle trig. To get this angle theta for the final polar coordinates, we need to take the whole circle 360 minus this row piece to get how far around we go. So, any questions before we jump into trying to do two examples? All right, first one is the harder one. Let's go from rectangular to polar. First step, either way that we're converting, is to draw the picture. So we are going to go -4 horizontally, -7 vertically. So our vector is something like this. As far as a triangle is concerned, sides are positive. We make the triangle with the x-axis. Rho is always an angle between the vector and the x-axis. We never draw across to the y-axis. So there's our triangle. I need to find r, and I need to find what that angle is. So r first. How do I find r for a problem like this? Ian? Just look at the picture. I know the 4 and the 7. How am I going to find how long the vector is? Pythagorean theorem. So r is going to be the square root of 4 squared plus 7 squared. Square root of 16 plus 49. Help me out with the calculator. What is the approximate value for the square root of 65 going to be? Zoe, you've got it? So that means when I write this in polar form, I'm going to have 8.062 at some angle. Questions so far? Okay, now I need to find what my angle is with right triangle trig. So I know the 4 and the 7. So which trig ratio? So the tangent. So I can rederive the formula that we wrote down. I can say the tangent of rho has to be, I'm ignoring the minus signs as I write this down, opposite over adjacent 7 over 4. So rho is the inverse tan of 7 over 4. Since I ignored the minus signs, that's what I meant about the absolute value. Now you may also just memorize the formula that we wrote down. Rho is the inverse tan of the absolute value of j hat over I hat. Or you may rederive it each time. Help me out. What do I get on the calculator? You got it already? Mm-hmm.
The calculation, you get 60.25.
Okay, so 60.225 degrees. So I wrote it right, I just said it wrong. Okay, 60.255. So that is our angle inside of the triangle. Those angles will always be positive. Never write down negative for your angle inside of the right triangle. Is 60.255 what I want to put here for my actual theta? Because I need to be here in the third quadrant, and if I just did 60, that would put me in the first quadrant. So this part is 60. What I need for theta is all the way around to there. How do I get that? Helen. So I'm going to take 180 plus my rho so that I get 240.255 degrees. Does that one make sense? Okay, now reread the directions. It said find 4 forms for this, and I found one way of writing the answer. I need to find 4 more. So the next one that I'm going to do is I'm going to say, well, to get to that vector, it's still 8.062 long no matter what, but I could have gone and measured my angle negatively to get there. So I could be measuring it like this. So I'm not going to do that as 90 plus something because I don't know what this is. I know this part right here is rho. So if I thought about, well, how far is it all the way around to here? And then take away the rho, I'd have what I really want. So negative in front of it, but the magnitude will be 180 minus rho. So store this on your calculator, call it whatever you want, store it as X or P or V or whatever letter you like. Do 180 minus rho for me, and what do we have? Mia? So everybody okay to there? Okay. The other two ways that I can write this are if I do a negative 8.062 out in front. Anybody remember what the negative out in front does to a vector? Ronald? It's 180 degrees opposite. So if I talk about this vector, but with a negative in front of it, that means this vector really flipped here. So what I need are the positive degrees for this, and then the negative degrees going around that way. Positive's the easy one. I've figured out that rho is about 60 degrees. How does rho compare to this positive angle that I want right here? Why? Vertical angles. So all I need on that one is 60.255 degrees. Now to go all the way around this way, that's going to be 360 minus rho, but going in the negative direction. So what do I get with 360 minus rho? Matthew? Is that making sense to everybody? And number 6 on tonight's homework does ask for all 4 forms. So that's why I wanted to review it. If they only ask for one, the best form is positive, positive, because that's the clearest to everybody. Okay, good news. When we convert to rectangular form, how many ways are there to describe with rectangular coordinates that you go across this far and you go up and down this far? Just one, so we're only going to have one answer this way. So that's going to be the good news. So first step is draw the picture. So we get our coordinate plane. We have a negative angle, so I need to go clockwise to get there. So 90, 180, 270 is too far. So negative 253 degrees puts me in the third quadrant. And in fact, I went 73 degrees past the 180 to get there. So is everybody good with that? Is where negative 253 degrees puts us. Now I need to deal with that negative 13 out in front. It's going to be 13 long, but what does the negative do to that vector I just figured out? So I don't really want up there in the second quadrant. I am really interested in this one down here in the fourth quadrant. So I need to draw my right triangle with the x-axis, and then I need to figure out what this I hat and j hat would be. If I'm in the fourth quadrant, what can you tell me about positives and negatives? Hope, what can you tell me? So I need to end up with a positive I hat and a negative j hat if I am in Q4. That's what I'm talking about. Think about the quadrants to figure that part out. So I need the angle between my vector and the x-axis. What will that angle be? So we have the vertical angles again. So I know this is also 73 degrees. I need to get for rectangle, and that's 13. Need to get that on there. If I want I hat, and I know the angle and the hypotenuse, which ratio is it for I hat? Cosine, I can rederive it. Cosine 73 degrees is I hat over 13, or I can memorize the formula. I hat is 13 cosine 73 degrees, and you're going to tell me what that is. And J hat is 13 sine 73 degrees. I want to see that written down, that you're entering 13 sine and cosine of 73 degrees. So I'll give you a moment to get that entered and tell me what answers you're coming up with for that. Ashani, you have it already? Do you have either of these already? Well, then borrow mine when you don't have yours in here sometimes. What'd you get? Okay, so I hat is 3.801. What about J hat? Who has J hat for me? Emma? So then I need to write my final answer. Fourth quadrant, positive, negative. So positive on the I hat, 3.801 I hat. Negative on the J hat, 12.432 J hat. And if it helps you any to memorize which one's which, I and J, alphabetical order. Cosine and sine, also alphabetical order, if that helps, if you're trying to just remember the formula and not rederive it each time. Do you guys have any questions? Okay, then I will let you guys start on your homework. Either